Okay. Maybe I'll do this on paper because make my video bigger, but the part that I actually have on the board, I added some more words in. The part that you have on your paper is kind of what all the pre-calc teachers hand out. But I like to think about transformations since we've been doing those. I like to think about this as being transformations. When we talk about the amplitude, this is just summarizing everything. When we talk about the amplitude, that's the vertical stretch. And when we talk about the finding the period, you have to use the horizontal stretch to find the period. Just whatever you multiply your x's by in the column, that's what you multiply your 2 pi to get the period. The phase shift is what we're doing new today. The phase shift is just the horizontal translation. So either left or right, and how much. And then the vertical shift we talked about last time, that's just if the graph's going up or down, and where it's located. So our first example is y equals sine 2/3 x minus pi over 6. If you are working ahead of me, I hope you are working in pencil just in case you make a mistake if you're working ahead of me. So what you want to start doing is think about the transformations so we know where to put them in the table. I first come to a 2/3. It's inside of the parentheses. What does that tell me? Horizontal stretch by a factor of 3/2. So that means I'm going to multiply all my x's by 3/2. And remember, if it's horizontal, we reciprocate it. We multiply by the reciprocal. And then we come to minus pi over 6. And you guys tell me that is what? Translate right, not pi over 6. Who can tell me why it's not? It is right. That is correct. It's going to be right. But why? Remember, we're chapter 1. Ooh, you got to factor that out. Remember? So if you look at the formulas, you will see this. They call it the B value. That horizontal stretch or shrink has to be factored out of the parentheses before you know what the translation is. Has to be factored out. So we will go factor that 2/3 out. I'm going to rewrite it as sine 2/3 parenthesis x minus. When we factor it out, you're dividing out 2/3. Can I divide by 2/3? Can I divide by 2/3? Multiply by its reciprocal, so we will have pi over 6, multiply by 3/2. That gives us pi over 4. So I'm actually adding, I'm going to the right, pi over 4. And this is a sine graph, so if you don't have it memorized, do not get this wrong. Like, draw a little graph, say, here's my ordered pair 1, 0, here's my ordered pair 0, 1. What is sine at 0 degrees? 0. What's sine at pi over 2? 1. And then you can, if you need to draw more of them, do that. Otherwise, you can follow the pattern where it's alternating zeros and -1 and +1 and so on. Then we're going to multiply all of our x's by 3/2. So remember, when you multiply fractions, you multiply straight across. So I'll get 3 pi over 4 for this one. I'll get pi over 2. I'll get 9 pi over 4.
Is it 3 pi over 2?
Yes, sorry. Totally is. Seeing if you're paying attention. Good job. And we'll multiply this one by 3 pi, or 3/2, and then we'll get 3 pi. So that would be just multiplying fractions. Then what we're going to do is we're going to add with a fraction. So 0 plus pi over 4 is pi over 4. And then if I add 3 pi over 4 plus pi over 4, yeah. know you talk like that, but there's a lot of people that. And then 3 pi over 2 plus pi over 4, I'm going to have to find a common denominator. So that's going to be 6 pi over 4 plus pi over 4, which gives me 7 pi over 4. 9 pi over 4 plus pi over 4 is going to be 10 pi over 4, which reduces to 5 pi over 2. And then 3 pi is the same thing as 12 pi over 4 plus pi over 4, so 13 pi over 4. So again, you need help with fractions, come get help. Now we're going to graph these. There's no transformations on the y side, so we're going to graph pi over 4, 0. Oh no, pi over 4 is not on my graph.
In between 0 and pi.
It's exactly in the middle of 0 and pi over 2. So I'll go to the exact middle and put a point. And then pi, that's on the graph. 1. Oh no, 7 pi over 4 is not on the graph. Oops, I didn't go to 1 either. 1. Okay, and then, oh no, 7 pi over 4 is not on the graph. So what I would suggest is, there's a couple, few ways to do this. All of the x's are always spaced evenly. So if I look here and horizontally, I look at how far apart the x's are. How far apart are they, like unit-wise, like boxes? 1.5 boxes. So the next one, 7 pi over 4, has to be 1.5 boxes apart. It has to be. That's one way you could figure it out. Another way I could figure it out would be to go graph another one that definitely is on there, like 5 pi over 2 is on my graph at -1. And then if I go exactly in the middle of pi and 5 pi over 2, that's where that third dot would be. So that's another way of figuring it out. These are all evenly spaced, so you should be able to find the ones that you don't know where the numbers are without doing too much extra work. I would like you to have the least amount of work as possible. Okay? Then we follow, well, that's this part. Then we're going to follow that pattern for the rest of our graph. And they're all 1.5 boxes apart. So that's how I'm doing this, is I'm going 1.5 blocks for each one. That's how I'm finding the rest of them. So I made my purple one is just the original points, just so you can see after I've connected everything where my original one was. Now we need to know the period, and the period is always 2 pi unless we have a horizontal stretch or shrink, which we did. So whatever I multiplied my x's by, multiply 2 pi by as well. So what is my period?
3 pi.
3 pi. The amplitude is the same as the vertical stretch or shrink. Did we have a vertical stretch or shrink?
No.
So then what is it? So it's 1. The sinusoidal axis is that line right in the middle of the graph. It's a horizontal line. It's called the midline. If I look here, it's always y equals 0 here. Phase shift is the same thing as the horizontal translation. So our horizontal translation was right, it was plus, but it's right pi over 4. So you're going to, I'm saying too many rights in a row that mean different things. You're going to W-R-I-T, R-I-G-H-T. You're going to write pi over 4. So you write that back into 2. What's another word for right? What? No, not that right. The other right. Escribe. That's totally what I wanted to say, but no. I know, but not everybody comprendes. Or comprendo, or comprende. I took Spanish in high school. It's been a while. It did help me get out of the sticky situation, though. Story to follow. Domain, negative infinity to positive infinity. And then range would be the lowest value, which is -1 to +1. See, so the only thing new is the shift. Let's do another one. Now, if I'm going too fast, I'm recording this video. You can watch it. Or you can ask me questions for it. All right, so you look at this equation, we're going to start writing down the transformations. So 3 out front is a vertical stretch, and we multiply our y's by 3. 1/2 after the word sign. It's a horizontal stretch, factor of 2. The pi over 2 inside, left, is it pi over 2? Why don't I have to change it? Because it's already factored out. Good job. Pi over 2. And then the -2 would be translate down 2. I would like to fly through this one kind of and just talk about this information and then do the last one all the way. So, because a lot of this information we could do without even filling out the table. And when you do have a quiz or a test someday on this, there's going to be some questions that I just ask for, what's the period? And you don't have to graph the whole thing to figure that out. So what's the period normally? 2 pi. But for this one, I multiplied my x's by 2. So do the same thing to the period, which is a horizontal length. What's my period going to be? 4 pi. And I did that without a graph. The amplitude is 3. Why? The vertical stretch or shrink. It's always positive. The sinusoidal axis. This one might be a little bit more tricky to do without the graph, but I'm going to help you out. Normally, the sinusoidal axis is at y equals 0, unless we have a what? Sinusoidal axis is this. How would it possibly be somewhere else? If I go up or down, a vertical translation, it's going to move it up or down. Do we have one?
Yeah.
So where? It's going to be y equals -2. The phase shift is if we're going left or right. Are we? Left? How far? Pi over 2. Our domain, maybe infinity and positive infinity. And then the range, this one is a little bit harder for me to do without filling out any information. So the range, I would probably need to fill out some information, but the range is only the y values. So I don't even need to fill out the x's. Unless I was graphing it, which you should, but we're not going to take the time to do that right this second. So this was sine, so it starts at 0. Oops. Yeah. Okay, so look at my y values. What's the lowest and highest y values? -5 to +1. See, I can even find all that information and I didn't even graph it. Okay, so the more you practice, the easier to get. But like when you do this in your homework, you're going to graph it as well. All right, last one. I want you to start trying it on your own. And I would make sure that your table matches my table before you graph the whole thing and realize you did it wrong and have to start over. So I'll put my table up. You check your table with my table before you graph the whole thing. Okay? Don't just sit here and copy my table. Try it on your own first. once you filled out your table, then check it with mine. Right. But that's, well, what's it do to graph like transformation? Vertical. I'll put it on the next side. Can you hear my because horizontal is everything you do is opposite operation. So if I'm multiplying by 2 to actually fit, we have to divide by 2. Just like inside, if we're adding 5, then you should be subtracting 5. Everything horizontal is always opposite. And that's what we were just solving. I realized myself. Subtract 5 on both sides. Fraction. Yeah. So if you have checked your table and your table looks like my table, then feel free to keep going and graph. I will put the graph up. And then you guys have 2 assignments you can be working on also once you're waiting for my graph to go up. I'm going to show you a mistake that I'm going to take off on if you're doing it. Show you a mistake that people do. Okay, this is a common mistake that I see. Do you see how some people will like go through that last point and just keep going? But when you look overall at the graph, what do we know about the very lowest point? When we talk about the range, the lowest point is at -2. Can it go below that? No, so you show me at the end of your graph, undo what I did, that it just starts to go back up. Okay, because the very lowest point or the very highest point, is there. You can't go above or below it. Oh, it's acting up. And then I do have the information below. I can only show you a little bit at a time. Check your graph. And I'm going to put the information below. I'm going to put it back up. And then if I went too fast, we can put this back up. But I don't need to make a video of just people staring at this for a while. Okay. So here's the information at the bottom. And I would like to make an extra dot, so I just made it to a 5. So there is a 4.5 worksheet number 2, and then you also have number 3, which is that 5-question, piecewise function to work on, and you'll probably have some questions for me. So I'll answer as long as I can.